Hello, everyone. Thank you for joining this webinar session. Today, we have the honor of having Krithika with us from M-System Technologies. And she's going to be covering a very interesting topic, which is modeling threats and vulnerabilities. But how do you do that through secure CI/CD pipelines, and also using how the chef manage that and help work within that. So very excited to learn more about kind of this emerging topic. So Krithika, thank you so much for being with us today, and the floor is yours.
Hello, Don. Thank you for the good introduction. Hello, everyone. This is Krithika. I'm here to talk about modeling threats and vulnerabilities for secure CI/CD through Chef automation stack. To give a bit about me, I'm Krithika Srinivasan, working as a lead DevOps engineer with M-Sys Technologies. M-Sys is a company, is a leading product solutions provider company, which basically deals with storage and automation. M-Sys started its operation with USA with around 5 to 10 people, and now we have grown up to 1,700, spread across 5-6 countries in the world, say USA, Malaysia, Vietnam, India, Australia, etc. So, and it is performing with a lot of our colleagues and what an M-Sys is just this is something that I wanted to say about my company. Regarding today's topic, I would want to touch base on how the security is a major aspect in today's pipeline, like how DevSecOps is gaining popularity, and how it actually deals with implementing security with your containerized integration, deployment and delivery, and implementing testing and other things. And also, the discussion will revolve around the chef automation stack, the integrated tool set provided by the chef in accomplishing the tasks that we wanted to cover, and also how DevSecOps team will help, DevSecOps implementation will help in securely managing and deploying applications by maintaining consistent delivery and security operations with minimal risks and vulnerabilities. So this is what I wanted to touch base on. And basically this entire presentation will deal with a lot of theory, best practices, processes to be followed rather than implementing something. So here it goes. So the agenda for the day goes like this. A bit of introduction to DevOps and DevSecOps practices, CI/CD concepts, good info on shift right and shift left testing techniques, and full stack deployment, security and monitoring for DevOps shifting left, threat modeling with DevSecOps, chef's role in CI/CD pipeline, and chef automation stack for secure CI/CD. This is the agenda for the day. DevOps, this is one term that we have been hearing of late. Like we see everybody implementing it, developing as a culture, mandatory practice in every organization that we deploy of late. Like every right from smaller companies to large organizations have started implementing DevOps as a practice. But the motto of DevOps basically deals with I would rather say, rather than a practice, it is a culture where it totally aims to integrate all the processes into one, right from the software development up till the deployment of product into production, and also deliver the products at a highly faster rate. The deployment velocity improves, and also the consistency of the product delivery and the quality of the software delivery. So DevOps basically integrates all this into one. And the culture is developing so that the entire process is automated and there is no manual intervention in any of these, and everything happens as a smooth transition. One major thing that I feel about DevOps basically is integration of different teams. Earlier, development teams were separate, testing teams were separate, and the operations teams were separate. This DevOps strategy basically brought in all three teams together, So all the three teams now work in close with each other, integrate with each other, bring out something that is mutual to all three of them, thereby delivering the quality of the software that is also developed, and deployed. The yet another term that is gaining popularity of late is DevSecOps. The DevSecOps basically integrates security right from the software development up to the deployment by effective security practices, by also implementing the needful DevOps practices. So this is what I would call a DevSecOps strategy. So DevSecOps basically involves implementing security policies in every stage of your product development lifecycle, say requirement analysis, product development, coding, infrastructure code development, deployment. In every stage, you implement some security strategy that basically handles security at that particular level. So I would rightly call it here, as I say it in this slide, that DevSecOps basically aims to provide the idea that everybody is responsible for security, rather than handling the security only at the production level, and only the production scenario is basically involving for the totally responsible for the security aspect. And also a few other terms that we've been hearing of late is continuous integration, deployment, and continuous delivery. So continuous integration, I would just want to quickly rush through this because this is something that everybody is aware of these days. So as soon as the developer commits the code to CI tool, that can be anything, just to name a few, Jenkins, Azure DevOps, GitHub CI, or whatever. So as soon as the developer commits the code and pushes it into the main branch, the trigger starts, the pipeline starts, a CI pipeline starts that will build the code, run all the necessary test cases, say probably at the code level unit test cases, and then build the artifact, package them into a specific packaging module that the code is intending to, and then pushes it into a storage artifact. So this process is completely automated, and there is no manual intervention during any of this process, like during any of this operations in the pipeline. So everything happens with a click of a button. So there are a lot of tools, mechanisms that handles this off late. The main intention of this is to provide that the software is bug free, because we are able to integrate a lot of testing solutions, code quality analysis, unit test cases tools into the pipeline, CI pipeline, which basically tests everything at the lower level with the feature analysis and then integrates into the major code. So this basically makes sure that a lot of bugs are reduced at the lower level rather than detecting them at the higher level, or the final stage of the deployment, say production or UAT environments. And also it also helps speeds up releases, because the issues are resolved at the earliest level and then picked up and then resolved at the earlier stages. This is about continuous integration. Continuous deployment is an extension of continuous integration, which is also included in the pipeline. That's why we call them as a CI/CD pipeline. As soon as the artifact is created by the continuous integration tool and it is stored into some storage repository, the continuous deployment tool would pull up that particular artifact, make sure that it is deployed onto the necessary server, or the server which is dedicated to that particular deployment, and make sure that the application is up and running by also setting up all the infrastructure needed for the application to run. So this is basically a continuous deployment setup. This flow is also entirely automated along with the continuous integration. How this implementation has been done, I'll cover up in the later stages, but for now, I would just want to touch that this is how the continuous deployment happens. And at every stage of continuous integration and deployment, so whenever a particular application is deployed onto a particular environment, say a dev environment, a continuous testing procedure also happens in parallel, wherein an automated scripted job triggers which will run a set of test cases, which would test unit test cases, of course, happens as part of continuous integration, but also some functional test cases, system test cases also happen, regression test cases happen during part of the continuous testing procedure, which also gets triggered along with your pipeline. So one single pipeline is now extended to take care of continuous integration, deployment, and the continuous testing procedure. So the entire delivery, deployment, integration to delivery is handled. Traditional testing strategy, traditional testing methods would basically test everything at the end. So once the product is finally up and running, so the entire content is basically tested for any of the issues, security practices, security vulnerabilities, threats, for anything at the later stages of the product development lifecycle. That's how the traditional testing methods were implemented. This costed them a lot of time and effort to find the bugs, remediate it, fix, find some mitigation measures and everything. There were a lot of test timing and cost involved because of the last minute testing. And since the module is already integrated and it is finally ready, they also needed a lot of time for testing and finding the bugs and mitigate it. So these to remediate this particular scenario, the term that we've introduced, or the term that has been introduced of late, is the shift left and shift right approach. I would want to cover on shift left now. So shift left basically refers to the cycle, part of software development life cycle, where the testing is mostly shifted towards the start of the software development life cycle. This applies to both the application code and also infrastructure code. So any bugs, any issues, any threats, it is identified and fixed at the start of life cycle or at every stage of life cycle, rather than implementing them or fixing them, identifying them at the end of the stage where the application is already into production. This reduces the time and effort, since we're identifying and fixing problems. It will reduce the longer test cycles and also the deployment bottlenecks. Handover times increase, frequency of deployments increase, velocity with which the project is delivered to the customers also increase. So there are a lot of improvements in the overall application development cycle and handover of your application by using the shift left approach. So shift left is something that can be achieved only through continuous testing processes, wherein testing means building and implementing the QA strategy throughout the throughout the product lifecycle, and not just any single module or any additional modules. How it is implemented is by testing on each phase, and only through some say, for example, when an application is in the staging scenario, application is continuously tested from top to bottom, and only if there are no bugs and it is completely okay to be moved on to the next environment from staging to production, only if the QA approves that the code is good to be transitioned to the production and it is good to be produced as a completed product in the live environment, the product will be moved to production, say progressed or approved to be deployed onto production. This is something that the shift left approach mainly focuses on. This V model is a basic of a software development agile strategy, where we have before the start of the software development, we do all this requirement analysis, system design, high-level system design, low-level system design, and also we integrate every stage with some testing approaches to eliminate the risks of testing at the last minute. Say, for example, right from the requirement analysis and the coding initiation, we try to do unit testing and also the system testing. So unit testing and system testing are basic blocks of testing, where like the testing is done at a very scratch level to find out and eliminate bugs and mitigate them. Acceptance testing and integration testing is done when we integrate the module, newly developed feature or a module with the final product, and also when the product is completely ready to be out live. So this is the basic V model that generally the software development lifecycle follows. How this particular testing strategies help with shift left testing is through these 4 types of shift left testing. So these are the 4 major shift left testing methodologies that companies would intend to follow. It is this traditional shift left testing, incremental, agile DevOps, and model based shift left testing. So the traditional shift left testing basically starts with testing at the scratch level, something that I discussed a few minutes back, like testing from the unit test, like starting from the code stages, testing the unit test, running the unit test cases and system test cases before the module is completely integrated to other components. So the focus will shift even left, say acceptance testing and integration testing comes later. The focus will shift even towards the end of the testing cycle, like unit and system testing. Incremental shift left testing is how do we do is like we break the entire testing, entire application testing into smaller modules. We test one module, the smallest module. We look out for bugs, find the resolution and mitigation strategies, apply them, fix it, and get it ready for application use. And then we integrate it with the second module. So now the testing focuses on the combined modules of 1 and 2 and how the integration happens and issues and resolutions as part of the integration. So that's how incrementally the testing will continue until the entire testing of the module or the project is complete. So that's basically incremental shift left testing. Agile DevOps shift left testing is basically the development and the testing happens with sprints. So for one sprint, there will be one module development. On one module development, there will be development and testing of the particular module. And then another end, there'll be, and then at the end of the sprint, after the development and the thorough testing, the application is integrated onto the original end product, end module. And similarly, the next sprint happens and it continues. Model-based shift left testing basically deals with a plan for the unforeseen errors that arise during and after the software development lifecycle. How shift left focuses on completely on testing from the scratch level. Shift right basically deals with testing testing for defects and vulnerabilities at the later stage of the product lifecycle. It basically finds out how the user perspective would be when a product is deployed onto production and it goes live. How what ways the user would get benefited out of it, what are the issues that user would face, and whatever the feedback that we receive from them is basically taken into consideration, and the metrics that we take from the customer feedback and also from other monitoring tools that we implement. So everything is taken into consideration, and continuously checking the application that is running, that is finally ready and up and running, to make sure like how better the application can be made and how it can actually withstand the user load, and ensuring no reduction in quality. There are some popular shift right techniques also, say alpha beta testing that everybody is aware of. Like we need to after the product development is complete and it is deployed, it is tested at the customer end and also at the development end. Synthetic monitoring is something like we need to have some automated scripts that can monitor the application, take some remediation measures to bring if something goes wrong. So everything is automated via some scripts and monitoring is set. Feature toggle is something like you intentionally enable a feature and then make sure that a particular feature is working fine. And in case of any issues, you should be able to toggle it back to the original state by disabling the enabled feature. Chaos testing is something like you need to introduce a lot of chaos, some unexpected load, something that is totally unwanted, to see how the system behaves in case of such extreme situations, how it handles it, how it mitigates it, what kind of reporting does the system make in case of such unmeasurable or unwarranted situations and all that. Canary releases is something that instead of deploying the components to the entire set of people, we would want to deploy it to a specific set, say 1 or 2 customers, just to test how it is actually impacting, or how it actually make sure that the product is working fine and the customer is satisfied before deploying it into a larger population. Blue-green deployments is having a even odd deployment servers where you deploy only to an event set or an odd. Say, for example, if you're deploying to event, you will have odd set with the old code, enable the event set, test for issues or test for any abnormalities, vulnerabilities, threats, and also any feature failures. If at all there is nothing and the testing is completed successfully, fine, you enable it and you deploy it onto the event odd set also. And you exploratory testing, there are a lot of the usual test cases that the company would cover as part of the testing lifecycle. Say you have around 15 test cases that you generally test for the product, involve around some 500, another 10-15 more that you would never expect, that the company would never assume that would happen. Explore all options, explore all varieties of issues that would occur, and then do all the testing scenario. So this is something that we are discussing about for the past few minutes. The shift left testing is basically this unit test, component, system services test, and integration test, which basically deals with the start of the application development lifecycle, say plan, design, code, test, build, this up till CI. So the shift left of approach basically deals with the release, deploy, operate, and monitor. Exploratory A/B feature toggle. This is all the basic crux of the DevSecOps concept is continuous testing. Testing at every phase for every scenario, say application feature or security threats. Setbacks with a CI/CD pipeline or something that would cause it threats and vulnerabilities. Major thing with security impact is something that I would want to bring in here. It is data non-compliance and non-prod environments. Generally, people tend to have everything compliant, everything ready only on the production side. So that is basically not very healthy setup where you can have everything set as per the rules only for the production environment. That particular strategy should be followed right from your development environment up till your application is in production, so that in every stage of your development or deployment cycle, this holds good for both application code and also the infrastructure code. So in every stage, in every environment, data compliance and other security compliance has to be maintained. And people generally don't set up monitoring for the initial phase of their product lifecycle. They don't set up audits for the initial phase. So basically this monitoring, audits, everything starts only when we deploy the application to a higher environments. Only if we do this auditing and monitoring approach, we will be able to set up this particular stage where you can provide a proper incidents response and mitigation plan. Only if you detect the incidents, you will be able to find out and devise a mitigation plan. Some of the best practices that I would want to mention here to reduce the security vulnerabilities as part of DevSecOps practices are these. So we want to model and simulate the threats and vulnerabilities by creating a threat environment. What I mean by this is, say for example, what if somebody tries to do some man-in-the-middle attack? Say somebody try to sniff into our network, say somebody tries to get into the source code. How do we approach that particular scenario? How do we determine the what's mitigation strategies that need to be followed? Everything has to be pre-planned, predetermined. Only then in case of any unavoidable circumstances, we should be able to act accordingly. And before we push the source code into the remote repository from our local machine, we should make sure that all the access control policies are set correctly so that the people who don't have access or who are not intended to have the access to your source code or your say logic strategy are not gaining accesses to edit, move, or update your source code, and also have them reviewed periodically. And one more thing is check for open passwords and secrets. Open source vulnerabilities also have to be, you can put in some vulnerability measurement tools where it can measure open source vulnerabilities like chef inspect, check marks, etc. to make sure that your entire vulnerability statistics is checked from the beginning of software development lifecycle, and also provide proper permissions for deployment and access control setup. Monitoring the deployment and issues posted is also very important. And yet another thing that people tend to forget or think that it is of least importance is cleaning up of the items that we don't need anymore. Say, for example, your source code, your CI/CD pipelines, your application servers, or your unused passwords and credentials, say like usernames and passwords, everything has to be discarded in a very, very diligent manner. Apart from continuous integration, deployment, delivery, testing, this is yet another term that people would want to remember is continuous compliance. So just like how testing is necessary at each phase to find out bugs from the application perspective, continuous compliance evaluation is also necessary right from your code development to deployment to make sure that at each stage of software development, the issues are captured and fixed so that they don't occur again in the production. One more process that necessarily deals with this entire DevSecOps operation is threat modeling. So threat modeling is basically evaluating the threats and vulnerabilities and also provide a mitigation plan to minimize the consequences or effects when the application is going live. This is threat modeling. So how basically threat modeling happens is by setting up monitoring. Monitoring is the major thing. So application, wherever it is deployed, has to be monitored periodically. So based on the reports, audit reports, say data analysis, whatever we gain from that, it is like setting up a periodic procedure where you take the necessary action to reduce risk, and also the inspection of the entire software is done from the start to the end. The threat modeling process goes like this. You have to identify the assets, be it the hardware or the software or the third-party inclusions that you make, whichever assets are threat vulnerable or something that would identify the assets that are threat vulnerable, and then that would like list down everything that would end up having some issues. This is just a major identification thing to make sure that the application, the entire system goes as per the required scenario. And we should also be aware of the entire architecture, and also the application we need to decompose completely. Like say, it is very difficult to do a threat modeling procedure for the entire application from start to end. So identifying the architecture and decomposing the application into smaller units, then identify the stages at which the threats would occur. Modeling is important and all that. So decomposing application is highly essential. And once you decompose, we need to identify the threats and vulnerabilities, document them, and then periodically rate them as how they're improving or how it is decreasing and all that. Now that we've spoken a lot about the basics of DevOps, DevSecOps, shift left, shift right, threat modeling, vulnerability, continuous compliance, and all that, I would want to come to this stage where how Chef is being used for this continuous integration, deployment, delivery, and also this Chef automation stack in the continuous compliance. Say how it assesses in the DevSecOps uh, DevSecOps practice. So instead of going through these, I would want to discuss with this particular architecture diagram that we have come up with. Say there is an application development that is happening here, and this is the Chef workstation where we do include all the cookbooks, data bags, security policies, and all that to deploy them onto specific environments. So whenever the application developer develops and commits the code to a feature branch and then issues a PR to master, the version control system would poll or trigger a pipeline, CI pipeline. This is a continuous integration pipeline, which will start building the code and then start running the unit test cases or basic whatever code quality analysis, security integrations, say some vulnerability analysis, and all that is being taken care by this Azure pipeline or Jenkins pipeline or any continuous integration tool that takes up this action. And then once the artifact is built, it is uploaded to an artifact storage system. So the setup CI completes with this app development to version control system with a trigger and a pipeline and artifact upload to a storage. And how Chef comes into picture here is with the continuous deployment strategy, we get to this stage of the architecture, say flow. This particular pipeline also makes sure that let us assume that the cookbook is already created, tested, and it is uploaded to a cookbook branch, and also tags are created. We make sure that the application versioning, semantic versioning, say for example, if the application maintains a version as 2.3.0, we make sure to maintain the cookbook tag and cookbook version also as 2.3.0. So every time the CI runs, the cookbook is taken from the version control system, be it Git or any version control system, and then the tags are updated to match the semantic versioning of the application, and the cookbook is uploaded to the Chef server. And data bags are also uploaded. Everything that needs to be done is automated through scripts as part of this Jenkins pipeline. So they will be ready for deployment in the Chef server. We also have security policies in place for every environment, right from the development to the production environment, which takes care of dealing with securities and threats and make sure that the application is deployed onto specific servers following a specific policy. Say the cookbook is taken from the Chef server and it is deployed onto dev server by following a dev policy, QA server by following a QA policy, and prod server by following a prod policy. So this is how the initial tightening of the security, and also for the cookbook edition and upload, we make sure that the access control is all set at necessary points so that there is no extra access given to anybody to view the cookbooks or view the data bags or view any secrets that are handled as part of so secrets are also put in the data bags, which so that they are not like, it is not open and no user can see it. The access control is all set. And also the policies will make sure that the application is deployed onto a dev, QA, and production as per the access control setup and other policy requirements. Major tool set that helps Chef get through this particular thing say this continuous deployment along with the continuous security. There are 5 Chef tool stacks that help the entire Chef module achieve this particular scenario. Chef Habitat, Infra, Inspect, Automate, and Workstation. This is something that everybody is aware of, but like I would want to emphasize that all the items put together constitute the Chef automation stack, which mainly focuses on getting the automated DevSecOps practice in place. So Chef Habitat basically manages the application packaging and deployment. And Chef Infra manages infrastructure. Both this holds good for both on-premise and cloud. And Inspect deals with security policies and predefined rules that we set, say for example in the previous example. And Chef Automate basically provides us a UI which can through which we can monitor. We should be able to observe and analyze. So Automate is basically for observability, and Workstation is for the developer to get a complete usability of the full enterprise automation stack. So the Chef enterprise automation stack basically deals with a set of tools which would help us get through this DevSecOps stack, DevSecOps into practice by embedding the code development, testing, compliance evaluation at each stage of the technology lifecycle. So why this is important is to enable consistency, velocity, and security in application delivery to any infrastructure. So basically this enterprise automation, say for example, you have a habitat file which would help in application packaging and deployment. That .hrt file that developed, that is created, can be deployed onto any environment so that the uniformity is maintained across all environments. That can be taken and deployed to an on-premise server and also to a cloud. So thereby maintaining the consistency across all platforms. So how this works is through these stages. I would call it triple D. That's how I set this up. Say define, deliver, and deploy. Define is defining the infrastructure, define the security policies, define the application requirements, everything as automated code. So the Chef code at the first stage basically takes care of defining everything. So the defined code is then pushed on to a Chef server. The Chef server on running a Chef client run will deliver the entire stack into a automated pipeline. Say when the Chef client runs, whatever is defined as a part of code will be executed and will be deployed onto the deployment environment. And once it is deployed, the automate and other tools help us monitor and observe the changes that is going on post deployment. So this is the entire flow. These are the steps that are followed as part of Chef automation stack in managing and handling security and also taking care of the application deployment. So this is the entire Chef automation stack. So the development team defines the entire automation stack as code from the Chef workstation, uploads the entire thing into a Chef server, and then once the pipeline like starts executing, say the Chef client run happens, the habitat, inspect, and infra make sure that the necessary tasks are done. And then like say security vulnerabilities are set, the habitat make sure that the entire code base is packaged and deployed on ready for deployment, and Chef infra make sure the infrastructure is ready. So all these tools come into picture from the start of the pipeline, and like it is available to production. Like every environment, it makes sure that the setup is handled and the same consistent setup is maintained across all environments up till the application is delivered onto production. So this is something that we discussed some time back, version control to pipeline, to artifact store secrets, to provisioning, and it can be deployed onto any stack, say VMs, containers, cloud, and this entire thing is handled through the Chef AAS. So this is the entire Chef AAS stack. So as part of this, I would want to help you with try and bring up a Chef Habitat with Chef Automate UI setup, which would help us monitor, deploy the applications onto cloud. Which would monitor unrun applications that is deployed onto any of these servers, say on-premise, cloud, or the containers. So these are system requirements for it: RAM, CPU, 54 CPU, 16 GB RAM disk space, and all we need is a Chef Automate, the latest version, and Chef Habitat minimum version of 1.5.0. And also we need to have a Chef Habitat service group defined with, like, say, one set of servers doing a specific operations are grouped into a specific topology called service groups, and they're also connected with the service group network, Chef Habitat supervisor network. So prerequisites are these: Chef Habitat and Chef Automate standalone installations, and we need to have a Chef Automate API token specific for this integration. So this API token can be obtained from the Chef Automate UI that we already have. And like of course, it is necessary to secure them, keep them safe during the entire course of operation. So it is definitely not okay to get the API key exposed. So how do we want to do it? Is like get to the Chef Habitat, customize the event stream command and execute it from the Chef Habitat command line. So we need a Chef Habitat and Automate installed, API key, and the Chef Habitat command line. So this command would is basically run this HAB is a Chef Habitat command line, and these are something that needs to be customized as per the requirements. Say the name of your application, the environment, dev or prod or UAT or QA, site name, physical site or data center or cloud, whatever region. So if it is an AWS server, it has to be deployed on, we have to provide the region where the application is deployed, on-premise, the data center name, etc. And Automate server's host name must be provided as a stream URL, and stream token is your API token. So this basically starts a connection between your Chef Habitat and the Chef Automate UI. But there is one more step that needs to be done is to authorize communication from your Chef Habitat to Chef Automate. So there is a security certificate that needs to be added, which is essential to authorize the communication from Habitat to Automate. So these are the steps that need to be followed. The certificate has to be taken by providing, like, the certificate is available at this location. We need to go extract the certificate and then add it to your SSL directory and copy to SSL directory, and also provide the security certificate as a parameter to your HAB run to make sure that the communication is established between the Habitat and the Chef Automate. So this makes sure that the features of Habitat and Automate are embedded as provided by the Chef automation stack, so that we should be able to package and deploy applications and also monitor if the applications are up and running without any threats and vulnerabilities post a deployment. This is a basic dashboard that will display all the applications that are running as part of this Chef installation, and applications infrastructure, dealing with Chef Infra, application with Chef Habitat, compliance with Chef Inspect. So Inspect basically reports if there are any security threats and vulnerabilities in the running applications, if it is compliant to the standards and all that. And if at all there is any discrepancy, the UI would definitely give a pop-up and it will report. So that's how the Chef Automate stack builds it is built and it is used with the DevSecOps implementation throughout your software development life cycle, starting from your development to the application and production. And thank you for providing me this opportunity. So this is me. I work with Chef on day-to-day basis. The Jenkins, Chef, Rundeck, Docker, AWS is where my major areas of expertise are. And I also hold a certification with Red Hat, and recently I hold a certification as a Solutions Architect Associate. I'm a Architects Associate certified. So thank you for this opportunity. Have a great one.
Excellent. Excellent. Thank you, Krithika, for walking us through kind of the methodologies that you and your team have developed and used to make sure that the products that you're creating are top notch in terms of functionality and security. So thank you very much, and thank you everyone for attending, and have a great rest of ChefConf.